हेलो स्टूडेंट्स, वेलकम टू द क्लास। तो व्हाट विल बी स्टडी टुडे? ये देखिए, ये क्या है? लाइट। ओके, तो सो वी विल बी स्टडीइंग लाइट टुडे, चैप्टर 1, क्लास 10 फिजिक्स। सो लेट अस स्टार्ट द क्लास। ओके, तो पहले व्हाट इज लाइट? व्हाट इज लाइट तो लिखते हैं। व्हाट लाइट पहले क्या है जान लेते हैं। लाइट तो आप चारों तरफ देख रहे हैं, वही है लाइट, रोशनी जिसे कहा जाता है। सो लाइट इज अ फॉर्म ऑफ एनर्जी। लेकिन लाइट किससे बना है? व्हाट इज लाइट मेड अप ऑफ? ठीक है, उसके बारे में दो थ्योरी है लाइट के बारे में। ठीक है, लाइट के बारे में क्या थ्योरी है देख लेते हैं। वन इज द वेव थ्योरी ऑफ लाइट एंड द अदर इज द पार्टिकल थ्योरी ऑफ लाइट। तो आप लोग लिख लीजिए, वेव थ्योरी में क्या बोला जाता है? अकॉर्डिंग टू द वेव थ्योरी ऑफ लाइट, लाइट ट्रेवल्स, लिख लीजिए, लाइट ट्रेवल्स in the form of waves. Okay, and और क्या बोला जा रहा है? It is also said that these waves do not need a medium to travel. इसका मतलब इट कैन ट्रैवल थ्रू वैक्यूम, है ना। सॉलिड, लिक्विड, गैस अगर प्रेजेंट ना हो, इफ इट इज एब्सेंट देन ऑल्सो लाइट कैन ट्रैवल। लाइट कैन ट्रैवल थ्रू वैक्यूम। सो लिख लेते हैं, लाइट कैन ट्रैवल थ्रू वैक्यूम। ओके, अब पार्टिकल थ्योरी ऑल्सो भी है। पार्टिकल थ्योरी भी कहा जाता है कि लाइट इज अ फॉर्म ऑफ पार्टिकल। ठीक है, तो उस थ्योरी में क्या बोला जा रहा है? इट सेज दैट लाइट ट्रेवल्स इन द फॉर्म ऑफ माइन्यूट, मतलब टाइनी पार्टिकल्स, वेरी टाइनी पार्टिकल्स, माइन्यूट particles called photons. ठीक है, and these photons can travel through vacuum. These photons do not need a medium. These particles can travel through vacuum. सो दोनों थ्योरी में ये बोला जा रहा है कि लाइट ट्रैवल्स थ्रू वैक्यूम। ये तो हम सबको मालूम है दैट लाइट कैन ट्रैवल थ्रू वैक्यूम। यू आर गेटिंग द सन्स रेज आर ट्रैवलिंग थ्रू स्पेस एंड रीचिंग अस। ठीक है, दैट मीन्स लाइट कैन ट्रैवल थ्रू वैक्यूम। सिंपल। देन लाइट के बारे में व्हाट एल्स डू वी नीड टू नो? वी ऑल्सो नीड टू नो, लिख लीजिए, what is a luminous source and what is a non-luminous source. luminous source किसको बोला जाता है? luminous source, source that emits light. source जैसे लाइट बल्ब, सूरज, सन। source that emits light, source that emits light of its own. Okay, is called a luminous substance. And what is a non-luminous substance? Non-luminous substance is one. Example क्या है? मून। मून रिफ्लेक्ट करता है किसको? सन्स रेज, है ना। सन्स लाइट रिफ्लेक्टेड बाय द मून। मून इज अ non-luminous object. That means what? It does not emit It does not emit light of its own. Example, moon. Okay, तो प्लीज कॉपी इट डाउन, लिख लीजिए, काम आएगा. Then we can travel on to the next topic which we want to study. That is the most important thing that we will be studying इस क्लास में, वो है reflection from curved surfaces. Okay, तो first copy it down. Okay, चलिए, now we will study reflection of light from curved surfaces. Plane mirror आप लोग पढ़ चुके हैं. Okay, you have already done plane mirrors. Now we will do reflection of light from curved surfaces. तो reflection of light कैसा होता है, you have already studied. We have already studied about regular reflection and irregular reflection. Reflection किसे बोला जाता है? Bouncing back. When light bounces back from a surface, that is called reflection. Regular reflection और दूसरा क्या था? irregular reflection. ओके, तो रेगुलर रिफ्लेक्शन में क्या होता है? सपोज वी हैव गॉट अ प्लेन एंड वेरी स्मूथ सरफेस, देन a parallel beam of light, when it falls on a surface, bounce back करता है ये this light, that is the reflection. Reflection is nothing but bouncing back of light from a surface. So when it bounces back from the surface इस तरह से, after reflection the light rays are parallel to each other. पहले भी parallel था before reflection from the surface. This is the surface from which the light is getting reflected back. Okay, so this is a beam of light. After reflection it is traveling parallel again. Okay, why? Because this is a smooth and polished surface. लेकिन irregular reflection में क्या होता है? We have got a this kind of surface, rough surface है. तो rough surface पे when there is a parallel beam of light falling on the rough surface like this. Okay, this is a parallel beam of light. After reflection ये इधर जा रहा है and this is going like this. So are they parallel? They are not parallel. So what do we see? Irregular reflection में the light, parallel beam of light after reflection gets scattered in all directions. Parallel नहीं है. Okay, so irregular reflection में लिख लेते हैं. What is irregular reflection? लिख लीजिए, एग्जाम में फटाफट फुल मार्क्स लाना है. एम फॉर 100 मार्क्स इन बोर्ड्स. ओके, चलिए, लेट अस सी. सो लेट अस राइट डाउन अबाउट इरेगुलर रिफ्लेक्शन फर्स्ट. व्हेन अ पैरेलल बीम ऑफ लाइट falls on a rough surface, क्या होता है? After reflection क्या होता है? On a rough surface, after reflection क्या होता है? When a parallel beam of light falls on a rough surface, after reflection they travel in different directions. इस तरह का रिफ्लेक्शन को बोला जाता है इरेगुलर रिफ्लेक्शन. आफ्टर रिफ्लेक्शन द रेज आर नॉट पैरेलल टू ईच अदर. वो भी लिख लेते हैं, ठीक है. After reflection the rays are no longer parallel to each other. ठीक है, ये तो हो गया इरेगुलर रिफ्लेक्शन। चलिए रेगुलर रिफ्लेक्शन का भी लिख लेते हैं। हाउ वी विल डिफाइन रेगुलर रिफ्लेक्शन? तो रेगुलर रिफ्लेक्शन में क्या लिखेंगे? व्हेन a parallel beam of light falls on a smooth polished surface, ये चमकता हुआ सरफेस है, स्मूथ पॉलिश्ड सरफेस, क्या होता है बताइए? स्मूथ आफ्टर रिफ्लेक्शन फॉल्स ऑन अ स्मूथ पॉलिश्ड सरफेस आफ्टर रिफ्लेक्शन they travel parallel to each other. Okay, so this is regular reflection. We have already studied about it in junior classes, class 8, 9 में we have already read about it. तो चलिए we will short में थोड़ा सा रिवाइज कर लिया. Now we will go on to the next subject, that is reflection from curved surfaces. Plane mirror you have already done, so curved surfaces करेंगे हम लोग. चलिए okay, now we will come to reflection of light from curved surfaces. तो कर्व्ड सर्फेसेस कैसा होता है ये बता देते हैं. सपोज हमारे पास एक ऑरेंज है. ओके, दिस इज एन ऑरेंज. आप ऑरेंज का एक पार्ट काट लोगे, ये जो पार्ट है आपको इस तरह का एक सरफेस मिलेगा. कर्व्ड सरफेस, अंदर कर्व्ड सरफेस है, बाहर भी कर्व्ड सरफेस है. सो दिस पार्ट हम लोग कट ऑफ कर लेंगे. कट करके इफ दिस इज द रिफ्लेक्टिंग सरफेस, दैट इज द इनसाइड इज द रिफ्लेक्टिंग सरफेस, और दिस इज द नॉन रिफ्लेक्टिंग सरफेस, पीछे वाला साइड जो है outside of the surface, if that is the non-reflecting surface and the reflecting surface is this one, then it is called a concave mirror. It is called a concave mirror. Okay, और convex mirror कब होगा? सिमिलरली इसी पार्ट को आउट ऑफ दिस फुटबॉल या ऑरेंज कुछ भी हो, इसका पार्ट काट लेंगे. उसका अगर आउटसाइड सरफेस इज रिफ्लेक्टिंग लाइट एंड ये ओपेक सरफेस जो है, ओपेक सरफेस विच, ओपेक मतलब दैट डज नॉट अलाउ लाइट टू पास थ्रू इट, उसको बोला जाता है ओपेक. दिस इनसाइड पोर्शन ऑफ द कर्व, और आउटसाइड पोर्शन ऑफ द कर्व से लाइट रिफ्लेक्ट होके जा रहा है. इन दैट केस इट इज कॉल्ड अ कॉन्वेक्स मिरर. ओके, तो कॉन्वेक्स एंड कॉन्केव मिरर का कॉन्सेप्ट हो गया. Now we will come to a few definitions. Definitions like आप लोग याद कर लीजिएगा बुक से, ठीक है, बता देते हैं आपको. ये एक स्फीयर है, स्फेरिकल स्ट्रक्चर है, इसका तो सेंटर होगा एक, इस बॉल लाइक स्ट्रक्चर का एक सेंटर होगा, उसका कुछ रेडियस भी होगा. इट हैज़ गॉट अ सर्टेन रेडियस, है ना. तो चलिए, तो इस ये जो रेडियस है, दिस रेडियस बोला जाता है इज द कॉल्ड द रेडियस ऑफ कर्वेचर ऑफ द मिरर. ओके, तो एग्जैक्ट डेफिनेशन यू शुड लर्न फ्रॉम द बुक. चलिए, रेडियस किसको बोला जाता है? एंड सेंटर ऑफ द स्फीयर इज दिस वन पॉइंट कॉल्ड सी. ओके, तो सेंटर ऑफ द स्फीयर लिख लेते हैं पहले. सेंटर ऑफ कर्वेचर किसको बोला जाता है? सेंटर ऑफ कर्वेचर ऑफ अ स्फेरिकल मिरर. ठीक है, हाउ वी विल डिफाइन इट. चलिए, इस तरह से डिफाइन करेंगे. द सेंटर ऑफ द स्फीयर ऑफ विच द मिरर इज अ पार्ट is called what? Is called what? Center of curvature. Is called the center of curvature. ठीक है, जिस स्फीयर से इस मिरर को काट के निकाला गया था उसका सेंटर जो था दैट इज कॉल्ड द सेंटर ऑफ कर्वेचर ऑफ दिस मिरर. ये मिरर का भी एक अपना एक सेंटर होगा, इसका भी एक सेंटर होगा, वेदर इट इज कॉन्केव और कॉन्वेक्स दोनों का सेंटर होगा, है ना. सो दैट इज कॉल्ड द सेंटर ऑफ कर्वेचर. नाउ लेट अस कम टू रेडियस ऑफ कर्वेचर. सिमिलरली रेडियस ऑफ कर्वेचर क्या होता है देखते हैं. रेडियस ऑफ कर्वेचर सिमिलरली यहाँ भी वही होगा. रेडियस ऑफ द स्फीयर, ये रेडियस है. दिस डिस्टेंस फ्रॉम हियर टू हियर, इस पॉइंट को P ले लेते हैं. द डिस्टेंस फ्रॉम सेंटर पॉइंट C टू दिस पॉइंट P, दिस डिस्टेंस इज द रेडियस, R ले लेते हैं. ठीक है, सो दैट इज कॉल्ड द रेडियस ऑफ कर्वेचर. तो लिख लेते हैं हाउ वी विल डिफाइन इट. So similar lines similarly we will define, okay, the radius of the sphere जिससे हमने मिरर को काट के निकाला था, the radius of the sphere of which the mirror is a part is called what? Is called the radius of curvature. ओके, तो रेडियस ऑफ कर्वेचर डिफाइन हो गया. चलिए अब दिस पॉइंट P को डिफाइन करते हैं. व्हाट इज द पोल P? दिस पॉइंट P इज कॉल्ड द पोल ऑफ द मिरर. तो हमने जो पोर्शन कट करके निकाला था, सपोज दिस एंड आई एम मार्किंग एज M and this end I am marking as point as N. M and N जो हमने काट के निकाला था, this is point M, this is N. ठीक है, इसका बीचों बीच जो डिस्टेंस है, द मिडिल डिस्टेंस बिटवीन M and N is called the pole. ओके ओके, तो पोल ऑफ द मिरर क्या होगा? द मिड पॉइंट है ना, द मिड पॉइंट. दिस डिस्टेंस इज कॉल्ड द एपर्चर. ठीक है, वो लिख लीजिए आप लोग. ठीक है, डिस्टेंस M to N. डिस्टेंस MN is called the aperture of the mirror of the spherical mirror. Okay, चलिए, now we are in a position to define what is the pole of the mirror. It is the central part of the mid, or we can say midpoint of the aperture MN. Okay, pole of the mirror is the midpoint of the what? Aperture. Of the mirror, midpoint. Okay, और पोल के बारे में और एक you have to remember one thing. When a ray of light comes from along the center of curvature, okay, comes from C, it will get reflected back in the same direction. तो लिख के रखिए, when a ray of light falls on the pole of the mirror, it gets reflected back in the same direction. सो ये पॉइंट C है, सेंटर ऑफ द स्फीयर. इसको सेंटर ऑफ कर्वेचर बोला जाता है. if a ray of light is traveling from in this direction and falls at the pole of the mirror, okay, like this, pole of the mirror, यहाँ center of curvature point C है, यहाँ से ray of light is traveling, it will get reflected after striking the pole of the mirror, it will get reflected back in the same direction. तो यहाँ in this case it was convex mirror, the reflecting surface is here, so the ray of light is coming from here and it will get reflected back in the same direction. Okay, concave mirror, convex mirror में. Is it understood? Next, what is the focus? Focus किसको बोला जाता है? Focus, another point we have to define is focus. Focus को किस तरह define किया जाता है? We have noticed that rays of light which are parallel to the, इसको principal axis बोला जाता है. Okay, the line joining the center of curvature to the pole is called the principal axis. So any ray of light that is traveling parallel to the principal axis, in case of a concave mirror, it will pass through a, ये भी parallel ray है, ये भी parallel ray है. After reflection, it is passing through a certain point on the principal axis. That point is called the focus, F. ठीक है? After reflection, we have to always put the arrow directions. Remember, in the ray diagrams when you are drawing in school, आपको arrow marks डालना जरूरी है, otherwise you will not get marks. Remember that. तो चलिए, now we are in a position to define what is a focus. और इसमें क्या होता है? In case of a convex mirror में क्या होता है? Convex mirror में when a ray of light is traveling, इस तरह से आ रहा है, parallel to the principal axis it is coming, okay, it will get reflected back in a direction like this. It's parallel to the principal axis. After reflection, it is getting reflected like this. What are we observing? Diverge कर रहा है. They are moving away from the principal axis, but they appear to be coming from a certain point on the principal axis. पीछे हम लोग dotted line लेंगे because the ray has not yet traveled there. We imagine that the ray has traveled there, but actual ray has not gone behind the mirror. It cannot go behind the mirror. So the divergent rays, the rays after reflection, appear to be what? Where? Converging at a point behind the mirror. In case of a convex mirror में actually meeting नहीं करता है, but they appear to meet at a point somewhere behind the mirror. You have to remember this. They appear to meet. Actual rays तो diverge होके चले गया इस तरफ. Okay? So यहाँ भी ये focus है. तो focus को कैसे define करेंगे? We have to define both in case of a concave mirror and a convex mirror. तो चलिए, focus we will define as when a ray of light that is, लिख लीजिए, that is parallel to the principal axis. I am writing in short, P dot A, okay, principal axis, parallel to the principal axis. After reflection, ब्रैकेट डालिए, इन केस ऑफ अ कॉन्केव मिरर, in case of a concave mirror, after reflection appear to meet at a point on the principal axis, appear to meet at a point on the P dot A principal axis. Okay, this point is called the focus, लिख लीजिए. And otherwise definition in case of convex mirror थोड़ा सा different हो जाएगा. In case of different convex mirror में we will write when a ray of light is parallel to the principal axis, after reflection, convex mirror के केस में, they appear to meet at a point on the principal axis, ठीक है, that is appear to meet होगा. Sorry, there's an error here. 1 minute. चलिए, focus. A ray of light that is parallel to the principal after reflection in case of a convex mirror meets at a point on the P dot A means principal axis. This point is called the focus. This point is called the focus. Okay. और in case of a convex mirror थोड़ा सा different होगा definition. I am saying the definition, please लिख लीजिए. Okay. In case of a, ये हमने concave mirror का दे दिया है. They actually meet at a point on the principal axis. This point is called the focus. Okay. और in case of a ये जो है convex mirror में focus किसको बोला जाता है? Let us write down. तो लिखिए, when rays of light which are parallel to the principal axis after reflection appear to be coming from a point on the principal axis, appear to be coming, यहाँ से it is appearing as if the rays are coming from this point. Okay, they appear to come up from a point on the principal axis. This point is called the focus. तो हो गया, थोड़ा सा डिफरेंट होगा डेफिनेशन में. इन केस ऑफ अ कॉनकेव मिरर में यहाँ लिख दिया और कॉन्वेक्स मिरर मैंने अभी बता दिया आपको. ओके, सो लेट मी रिपीट. कॉनकेव मिरर में फोकस क्या होता है? व्हेन अ पैरेलल बीम ऑफ लाइट आफ्टर रिफ्लेक्शन मीट्स एट अ पॉइंट ऑन द प्रिंसिपल एक्सिस, दैट पॉइंट इज कॉल्ड द फोकस. और कॉन्वेक्स मिरर में क्या होगा? व्हेन अ पैरेलल बीम ऑफ लाइट, or you can write when a parallel beam of light parallel to the principal axis falls on the convex mirror, they appear to be coming from a point on the principal axis. That point is called the focus. Okay, so please write down the definition. Note कर लीजिए definition. Then we will move on to radius of curvature and focal length. Okay, to solve problems based on mirror formula, we have to follow a certain convention. Okay, what is that convention? Let us learn that convention first. The convention tells us that the object must always be placed on the left side of the mirror. Suppose this is the mirror. I am taking a concave mirror here. In this case, I have taken a concave mirror. Whether concave or convex, you have to place the object always on the left of the mirror. Okay, and the distances are measured always from the pole of the mirror. This point P is called the pole of the mirror. Okay, and the third is, suppose the object is here and the incident ray is traveling in this direction. Okay, so the direction of the incident ray will be the direction of measurement, that is positive. All distances that are measured in this direction will be positive, and all distances that are measured opposite to the incident ray will be taken as negative. So let us see, for example, in this case, what is the focal length? Focal length is the distance from the pole to the principal focus, isn't it? So for a concave mirror, the principal focus will lie here, somewhere over here, and the distance is being measured from the pole to this point. So it is opposite to the incident ray. That is why the focal length in this case for a concave mirror will be negative. Write down focal length F for a concave mirror will be negative. Okay, then what about the object? The object distance is also measured from the pole of the mirror. Okay, the direction of the incident ray is from left to right, and the distance of the object we are measuring from pole to object, that means opposite, isn't it? Opposite to the incident ray. That is why the object distance will be negative. Okay, this place is the object. So from, suppose this I am marking this point as point M. Okay, so this distance PM I am measuring from here. All distances to be measured from the pole. Okay, starting from here to here I am measuring the object distance, so that will be opposite to the incident ray, hence object distance is negative. Okay, for a concave mirror, object distance is negative. Object distance is denoted by the letter, small letter u. Okay, next we are coming to image distance. Okay, distance of the image. We don't know where the image is, so let us assume the image is somewhere over here. The image is somewhere over here. So what is the distance we are measuring again? The distance is always measured from the pole to the place where the image is. Okay, suppose the image is somewhere over here. The distance is measured from the pole to this, therefore that is in direction opposite to the incident ray, therefore it will be taken as negative. Therefore image distance will also be taken as negative in case of a concave mirror. So remember the formula. And what was the mirror formula? The mirror formula is 1 by V plus 1 by U is equal to 1 by F, where what is V? V is the distance of the image from the pole. Write down, V is image distance, okay, from the pole. What is U? U is object distance from the pole. All measurements are being made from the pole. Okay, remember that. And what is F? F is the focal length of the mirror. Focal length is what? Focal length is the distance from the pole to the principal focus. That distance is called the focal length. Now you have understood the concept. We can just apply in the formula and we can calculate the position of the image, object or the focal length, whatever is given in the problem we will be able to calculate. Okay? Hope you understood. Now let me explain the convex mirror. Okay, chaliye, now I am explaining convex mirror to you. The concept that is followed here, the Cartesian rule will be the same. Okay, whether it is a concave mirror or a convex mirror, the rule that is implemented will be the same. Now in this case I am drawing a convex mirror. ये convex mirror है. Okay, so where is the focus? Principal focus of the mirror will be on this side, opposite this side, and this is the reflecting surface. So the object we will place somewhere over here, and the incident ray is traveling from here to here, from left to right, and the principal focus is this point P. We know for in case of the convex mirror the focus will be somewhere over here. So we measure the distance from pole to focus. Okay, this is the distance we are measuring from pole to focus, that is the focal length. So direction क्या है? Direction same direction है, from left to right. Incident ray का direction भी this था, from left to right. So positive लेंगे उसको. Okay, so convex mirror में क्या हो गया? In case of a convex mirror, देखिए, in case of a convex mirror focal length F will be positive. Okay, object distance कहाँ से measure करेंगे? From pole to the location of the object. So I am measuring opposite to the incident ray. ठीक है, so this side it will be, U will be negative. Okay, और object जहाँ form होगा, if the object is, if we are getting, sorry, if the image I am getting on this side it will be positive, and if the image I get the image on this side it will be negative. Okay, just you have to make this law simple, just remember this. All the distances we are measuring, first point, remember, first point is that you have to place the object always on the left of the mirror. That was the first rule. Okay, and now for the remaining rules, you just remember, anything on the left of the mirror we will take as negative, and all distances on the right of the mirror we will take as positive. Okay, so that is more easy to remember. याद रखिए, distances on the left of the mirror we will take as negative, and distance on this side of the mirror is taken as positive. And another rule है, from the principal axis, height of the image object जो लेंगे, above this axis we will take as positive, और if the image is like this, suppose if the image is inverted like this, तो image का height we will take as negative because it is below the principal axis. So that was the last rule. What does the last rule say? Last rule बता रहा है कि principal axis के ऊपर जो भी height लेंगे हम लोग, that will be taken as positive. इमेज का जो ऑब्जेक्ट का हाइट ले रहे हैं, एंड इफ द इमेज का हाइट हम लोग नीचे आ रहा है, वी आर मेजरिंग द हाइट बिलो द प्रिंसिपल एक्सिस, दैट विल बी टेकन एज नेगेटिव. ओके, और एक भी फॉर्मूला लिख के रखिए. व्हाट इज मैग्निफिकेशन? मैग्निफिकेशन m इज इक्वल टू इमेज साइज डिवाइडेड बाय ऑब्जेक्ट साइज. So size of the image divided by size of the object is equal to magnification of the image, m, denoted by the letter m. ठीक है? This is also equal to, this thing also is also equal to image distance from where? From the pole of the mirror. Image distance divided by object distance. Okay? And in this case we will take minus v by u. Image distance minus v by u is the magnification, okay, where v is the image distance and u is the object distance. So remember, what is the formula we are getting for calculating mirror problems? 1 by v plus 1 by u is equal to 1 by f. This is the formula we'll use. And for magnification is equal to minus v by u, where v is the distance of the image from the pole and this is the object distance from the pole. Okay, यहाँ पॉजिटिव साइन है तो याद रखिए कि मिरर में यहाँ पॉजिटिव साइन होगा, यहाँ नेगेटिव साइन होगा. दैट इज़ व्हाट यू हैव टू रिमेंबर. और लेंसेज व्हेन वी डू यू विल फाइंड दैट वहाँ कुछ रिवर्स होता है. ठीक है. और फोकल लेंथ, अनदर पॉइंट दैट यू हैव टू रिमेंबर इज कॉन्वेक्स मिरर. Convex mirror, in case of a convex mirror, focal length f is always positive. ठीक है. तो कॉन्केव मिरर के केस में नेगेटिव होगा फोकल लेंथ. अदर थिंग्स यू विल फाइंड आउट फ्रॉम द कैलकुलेशन जो आ रहा है. तो ट्राई टू रिमेंबर दिस. ठीक है. तो क्या क्या हमने डिस्कस किया? पॉइंट नंबर 1 वाज, जो मिरर है वी विल टेक द ऑब्जेक्ट ऑन द लेफ्ट साइड ऑफ द मिरर. ओके. Then whatever distances are measured from left to right, that is the direction of the incident ray, that will be taken as positive. So यहाँ convex mirror के केस में हमने measure किया था focal length from P to F. This is this direction, left to right, same direction as the incident ray. तो ये भी positive लेंगे. Okay. So focal length of a convex mirror is positive and it is negative in case of a concave mirror. तो इतना याद रखिएगा. So now let us try to do a few problems based on this. Okay. Another thing I want to mention here is something about magnification. Okay. And the nature of the image. If, write down point number 1, just write down this point. If the image is virtual and erect, then magnification m is equal to positive. Magnification will come out to be positive. Okay. Point number 2, if the image is real and inverted, magnification m is equal to negative. Magnification will come out as negative. Okay. This is what you have to remember always while doing the mirror problems also. That is what, in this case, image is virtual and erect. This is what generally happens. Image is virtual means the rays do not actually meet. They appear to meet at some point behind the mirror. Okay, that is called a virtual image. and in that case we get a erect image. In such a case, magnification will come out to be positive. Or when the image is real, that means what? After reflection, the rays of light are actually meeting at a point. In such a case, you will get a real image and an inverted image. In such a case, magnification, value of magnification will come out to be negative. It's common sense, isn't it? Suppose this is the principal axis. We have got a mirror here. The object distance we are measuring above the principal axis, that is positive, and all heights below the principal axis is measured as negative. So magnification we know is height of the image divided by height of image divided by height of object, isn't it? Let me write down in short form: height of image divided by height of object. If the height of image is negative below the principal axis, it will be negative, and height of object is always positive taken above the principal axis. So negative divided by positive, this value will always come out to be negative. So in case of a inverted image, your magnification will come out to be negative. Remember this, okay? It will become more clear when we do a few problems based on mirrors, where we have to find object distance, focal length, image distance, magnification and so on. तो एक दो problems करेंगे, then you will find it easier to understand. Okay, let us start a few problems and do a few problems. चलिए. Okay, write down. You are given a convex mirror. ठीक है? Problem. This is a problem we are doing. You are given a convex mirror which has got a radius of curvature. Write down radius of curvature दिया हुआ है 3 meters. Okay, radius of curvature दिया हुआ 3 meters, and the object is located, object distance u is 4 meters. Okay, object distance is 4 meters. Now they have asked you to find the nature and the position of the image. Find the nature and position of the image. ठीक है? We have to also find the size. Also find the size of the image. Okay, size of image. So let us see what the size of the object is given to us. Size of the object is not given to us, so what we have to find is just we will calculate the magnification. Okay, magnification has to be calculated, and they have told us that this is a convex mirror. Okay, this is a convex mirror. So for this, what is given to us, let us now go through it again. It is a convex mirror where radius of curvature is 3 meters, the object distance is 4 meters. They have asked us to find the nature and position of the image, also find the size of the image. Okay, so let us try this. Come on. Remember this, radius of curvature is always double, isn't it? So in other words, focal length is half of the radius of curvature. Focal length is equal to radius of curvature divided by 2. तो focal length क्या है in this case? Convex mirror का focal length क्या होगा? F in this case is equal to 3 divided by 2, that is equal to 1.5 meters. Okay, so first of all we will write down the mirror formula. Mirror formula is 1 by V plus 1 by U is equal to 1 by F, where V is what? Image distance, U is object distance, and F is the focal length. तो चलिए एक रफ डायग्राम फर्स्ट वी विल ड्रॉ. ये है आपका कॉन्वेक्स मिरर. कॉन्वेक्स मिरर में वी विल टेक फोकल लेंथ टू बी पॉजिटिव बिकॉज फोकल लेंथ इज ऑन दिस साइड, तो ऑब्जेक्ट इज समवेयर ऑन दिस साइड. ओके, फोकल लेंथ कितना आया था? 1.5 फोकल लेंथ एफ, एंड ऑब्जेक्ट इज समवेयर ओवर हियर. तो यहाँ चलिए, नाउ ऑब्जेक्ट विल बी व्हाट? वी आर मेजरिंग ऑन लेफ्ट साइड ऑफ द मिरर, सो ऑब्जेक्ट डिस्टेंस विल बी नेगेटिव. The convex mirror, so focal length will be positive. Okay, so let us write down. So this formula then becomes 1 by V plus object distance was how much? Object distance was 4 meters. Okay, on this side of the mirror we are measuring from pole to the object. Okay, so it will be negative minus 4 is equal to focal length. Focal length 1 by focal length 1 by f. So 1 divided by 3 by 2 or 1.5, whatever you want to write. So 1 by 3 by 2 becomes 2 by 3. Okay, and so this becomes 1 by v minus 1 by 4 is equal to 2 by 3. Okay, therefore 1 by v is equal to 2 by 3. Bring this on the other side, it will become plus 1 by 4. So LCM karo iska, LCM is 12. Okay, so this becomes 8 and this becomes 3. Okay, so what are we getting? We are getting 11 by 12. 1 by v is equal to 11 by 12 meters. Therefore v is equal to, therefore we are getting image distance is equal to 12 by 11 meters. Okay, what does this mean? This means its value has come out to be positive. Okay, that means what? The image is on this side of the mirror, behind the mirror. That means it will be a virtual image and an erect image. Okay, v has come out to be 12 by 11 meters. Okay, positive value is, therefore the image is on this side. Positive means what? It will be virtual image behind the mirror. Rays of light are not actually meeting, they only appear to meet behind the mirror. So virtual and erect image मिला है हमको, therefore magnification has come out to be positive. ठीक है, now क्या बाकी था? What else was left? They have asked us to find the value of magnification, जिससे हमको size of the image आएगा. Okay, तो magnification formula we know is for a mirror is equal to 1 minus v by u. तो magnification हमारा आएगा, v का value is 12 minus 12 by 11 was v का value and u का value was, u का value कितना था हमारा? u का value was minus 4. Okay, minus 4. So minus minus will get cancelled, so we will get 12 by 44. That is your 12 by 44 is your magnification. Since it is less than 1, it's a fraction. 12 by 44 is less than 1. That means it will be a diminished image, smaller in size. The image is smaller in size as compared to the object. Okay, ठीक है? Hope you understood this problem. We will do another problem based on concave mirror. तो तब you will become more clear. तो चलिए, let me find out a problem based on a concave mirror and do that problem for you. Okay. Okay, write down this problem. This is a problem based on, this is problem number 2. This is a problem based on a concave mirror. पहला वाला जो था that was a convex mirror. तो in this case क्या होगा? Let us write down the question first. We are given a concave mirror of focal length दिया हुआ है. Focal length they have given you is 15 centimeters. Okay, focal length is given to you 15 centimeters. Object distance they have given you. Object distance is given to you as 10 centimeters. Now they have asked you to find, question is find position and nature of the image. Position and nature of the image. Also find magnification m. मैग्निफिकेशन का वैल्यू निकालना है. उससे हमको पता चलेगा कि इमेज जो है दैट इज लार्जर इन साइज देन द ऑब्जेक्ट और स्मॉलर और वॉट एवर. तो फर्स्ट ऑफ ऑल चलिए हम लोग कैलकुलेट करते हैं यूजिंग दिस फार्मूला. तो फर्स्ट ऑफ ऑल टू फाइंड द पोजिशन एंड नेचर ऑफ द इमेज वी विल राइट डाउन द formula, mirror formula first. 1 by v plus 1 by u is equal to 1 by f. Concave mirror बताया गया है. So far we readily get focal length will be negative. Okay. So focal length दिया गया था 15. So we will put as minus 15. Okay. So 1 by v this becomes 1 by v plus 1 by u जो था, and object is always ये है कॉन्केव मिरर एंड द ऑब्जेक्ट इज ऑलवेज इन ऑन द लेफ्ट साइड ऑफ द मिरर. दैट मीन्स ऑन द लेफ्ट साइड ऑफ द मिरर मीन्स ऑब्जेक्ट डिस्टेंस विल टेक एज नेगेटिव. ऑब्जेक्ट डिस्टेंस दिया हुआ था 10, सो वी विल टेक इट एज -10. और ये फोकल लेंथ ऑफ अ कॉन्केव मिरर है, सो इट विल बी टेकन एज नेगेटिव. 15 दिया हुआ था, दे हैव गिवन यू फोकल लेंथ 15, सो वी विल टेक इट एज -15. नाउ वी आर इन अ पोजिशन टू फाइंड v. v is the image distance. Okay, let us find out v. 1 by v is now equal to, take this to the other side, it will become 1 by 10 plus 1 by 10 हो गया. ठीक है, minus 1 by 15. okay, LCM निकालिए इसका 30. so this becomes 3 by 30 minus 2 by 30, that means is equal to 1 by 30. 1 by, what are we getting? 1 by v is equal to 1 by 30. Therefore v is equal to 30. Okay, v का वैल्यू इमेज what are we getting? We are getting plus. Image का distance we have got positive. What does that mean? This means the image is behind the mirror on this side, right side of the mirror. So what does that mean? Positive behind the mirror will be virtual image, and virtual and erect image होगा, है ना. So इमेज का लोकेशन मिल गया. इमेज डिस्टेंस इज इक्वल टू व्हाट? इमेज डिस्टेंस इज इक्वल टू 30 सेंटीमीटर्स. ओके, इमेज डिस्टेंस 30 सेंटीमीटर्स. नाउ लेट अस राइट डाउन. यहाँ फाइंड आउट करते हैं और लिखते हैं व्हाट इज the nature is virtual, behind the mirror. Virtual means behind the mirror. Okay, तो nature of the image हमको मिल गया. Now we have to find the magnification. Value of magnification is minus v by u. Okay, तो minus v कितना आया था? plus 30 आया था आपका यहाँ, plus 30. Okay, so we will minus 30. और ये क्या आया था? u का वैल्यू वॉज -10. So minus gets cancelled. So we are getting 3. 30 divided by 10, 3. Magnification 3. That means the magnification 3 times the size of the object. Image size will be 3 times the size of the object. तो object यहाँ है, we are getting it behind the mirror. So object का image will be somewhere over here. 3 times the size of the object image. And it is behind the mirror means it is virtual. Actual rays are not meeting behind the mirror, they only appear to meet there, and it is an erect image. Got it? Solve हो गया. Hope you understood. If you have not understood, please ask in the comments, or you can go through it once again. कर लीजिए, एक बार और प्रैक्टिस कीजिए. ओके, होप यू आर लाइकिंग द चैनल. इस तरह के वीडियोज़ आते रहेंगे. तो टारगेट क्या है? 100 मार्क्स इन बोर्ड एग्ज़ाम्स. ओके, नेक्स्ट ईयर. So please like and subscribe and ask in the comments anything you want to ask. Thank you, students.